Hey there, welcome to this lesson where we'll be doing some exercise. But before talking about what we are going to do, I'll talk about a little bit more about the fluids and give you more information about them, since before we looked at them very quickly. In order to explain the fluids, I'm going to use a scene, something simple. After that, I'll show you Real Flow's promotional video containing lots of examples of fluid simulations, and I'm going to use different scenes to explain to you how the different effects are obtained. So this is kind of the exercise we are going to do. This way you'll know which concrete and particular parameters agencies and producers used for getting these professional effects. Okay? So let's get started. Perfect. Here I've created this scene, which is quite simple. It's just a plane, and I've inserted a collide tag in order to prevent the liquid from expanding. That's why I'm going to increase the friction value as well. And okay, I think I'm going to set it, I think here is fine, like 0.200. It's fine, I think. Then we're going to add gravity to the scene, and within the meter, blow volume up to 20, so that instead of emitting a liquid, it emits out the volume of that liquid. This will let us see clearly how each fluid works. Well, before starting with the exercises, I'm going to explain the different parameters contained in the fluid panel. Great. I'm going to use this scene I just created as an example. Okay. Let's begin with the type liquid PBD. This is the one that comes by default, and it's the quickest option to simulate liquid. So it's the perfect option to start working. As you can see, here is the meter, and this is what happens. Great. And now I want you to see the difference between this and the option liquid SPH, which is the same we just saw, but much more precise. So when the project is ready and you want to improve the liquid's quality, instead of using PBD, use SPH. It's not that fast as the other one, but much more accurate when simulating liquids. Have a look at the animation on the screen. The particles fall apart considerably in comparison to the previous animation. Okay, let's have a look at the other one. See, it's like the liquid is heavier, right? And in the second one, the result is much more realistic. The particles or drops fall apart everywhere. Apart from these two liquids, there's another type called DAM, which unlike the other two isn't accelerated by the GPU. The DAM particles are often used for simulating spray or foam as well. These particles can't react with each other and don't have the characteristic fluid properties. But the advantage is that they are simulated very fast. Let's see how it works. Also, as you can see, it presents few parameters. The fluid falls down, but it's much more solid. Now let's move on to the next one, the granular type, which offers more parameters to adjust the fluid and is suitable for substances like sand or snow or elements with similar characteristics, okay? So this is the simulation generated by default. And in order to get a different effect, we can tweak parameters such as the damping. So I'm going to reduce it. Here it goes. If I blow it up like that, the fluid is much more solid. See? Okay, and again, this is what happens when we reduce it. Compactation and cohesion are also important parameters. For instance, if I reduce the compactation 1, I get a more fragmented behavior. It has more viscosity. On the contrary, if we increase it, it's more compacted now. Like sand or something like that. See? It's here now. It's something difficult to categorize it. There are lots of parameters that you have to explore to see how they work. Here we have cohesion, which determines how much compacted a fluid is, and is quite similar to the compactation type. Spot the difference after reducing the compactation and increasing the cohesion. It's quite similar. Almost the same, we can say. And if we increase compactation, the result is different. It doesn't look like sand anymore, okay? And then we find the viscous option, which is suited for substances like caramel, yogurt, oil, lava, liquid chocolate. If we select it, we'll find different parameters, and the most important is viscosity. Let's see the animation. Well, it's quite similar to the granular fluids. Then, if we reduce the viscosity, the liquid is less viscous, and if we blow it up, the fluid will be more compacted. There it goes, okay? Apart from this, we can modify other parameters such as damping or cohesion. If we set damping to its highest value and viscosity at an intermediate value, this is the result. Let's reduce also damping and increase viscosity. The result is also similar. We can also alter other parameters, like let's reduce cohesion and increase damping. Now it seems like Play-Doh. And after reducing the damping again, the liquid spills. See? But they are quite similar. And then the last fluid is the viscoelastic, which is great for materials such as rubber or silicone. Well, if in the animation we can appreciate it doesn't spill that much this time. Guys, I know it's hard to spot the difference between them, but if you look closely, you'll appreciate it. Let's increase the damping. and the liquid spills a little bit more now. Well, I'm going to reduce the viscosity, and now it's not that compacted, right? So, guys, we have lots of different options. The best part is that we can get quite different results by tweaking the parameters in the fluid panel. Important parameters, as we saw, are the damping, elasticity, viscosity, which, as their names suggest, work differently and produce different results, okay? So, well, I leave it here. I think I explained to you the main stuff regarding fluids. Remember that we've done all this with the measure enabled and has the following settings: a low medium resolution, radius at 8 and a smooth at 1. And depending on the settings, the liquid will be one way or another. However, if you want to avoid undesired issues, I recommend that you practice with these parameters: radius at 8 and smooth at 1.8, but not higher. Important, okay? Cool. Let's watch again this amazing video. I'm going to explain you how they have been developed. Although I won't go deeply into each of them since there are many other parameters we haven't looked at yet, like the shader or the specific creation of liquids. What I'm going to do is explain to you which demons and emitters have been used in some of them. Okay, so let's start with the first scene. Are you excited? Because I really am. Here we can see some raindrops falling on the ground breaking. Creating this effect is quite simple. Just need to insert different emitters. We can even use the cloner to ease the task. Obviously, we would need a collider for the ground so that the drops collide with it. Plus, if we set the fluid's volume to 20, volumes are created, and instead of continuous flow, drops are formed. The higher the volume is set, the higher the raindrops are. Don't forget to add a demon gravity in order for the drops to fall down. We can also select a triangle emission to enhance the result. Guys, it's really important to play around with the different effects and parameters until getting the expected result. In the next scene, we see some strawberries falling into a liquid, milk perhaps, and splashing. Let's have a look at the animation in slow motion. How can we simulate this splashing effect? We would use the demon crown. It's great for getting this result. My animation's effect is more exaggerated, but it's similar to the one of the video. To improve the animation, we could use a demon shader to fill the holes in particle fluids and get a smooth stream of particles. This slow motion effect is really cool and can be used in many cases. The next scene shows two dancers and the liquid follows the movement of the couple. To imitate this scene, we need to create a spline and link an emitter to this spline, okay? The spline's shape is decisive in this case in order to add a demon wind or noise later. Check it out. The emitter is oval and moves along the spline's path, creating this curious path. We could say that the next scene represents something more abstract. In order to create this effect, we need to insert a spherical emitter and then animate a demon like a demon noise. drag, or shitter. I think they would work fine in this case. Frames animation is essential here in order to get this spherical effect. This case is great for practicing, and we'll see it in an exercise later on. In the next animation, which is a kind of advertisement, we can see a heavy flow coming out of the bottle. How can we get this effect? Well, we would need a circle emitter at a very fast speed. It's important to insert a demon noise to the base in order to add turbulence and randomness to the flow. As you know, the noise shape can be modified. In this case, it's a cone-shaped. Guys, remember that materials are decisive for determining the liquid's aspect. Okay, and in the last scene we can see something similar, although in this case the stream of liquid follows a winding path and creates a subtle vortex. And how is it possible? That's it, with a demon spline, to which we linked a previously created spline. These options, together with some controllers we'll see in a future exercise, are great for creating this effect. And instead of a spline drawn manually, we can use a helix spline. We'll generate a helix path similar to the example on the screen. Okay? Well, are you ready to start practicing? We are going to do different exercises of up to 15 minutes, where we'll be practicing with some of the options and parameters we've seen throughout the course. You realize that with just few of elements, we can get really cool simulations. This lesson's goal was preparing the base for the practical part of the course and show you more examples of the different applications these tools have. Well, see you in the first exercise.